Okay, let's look at an example for quiz 7, problem number 4. Right? So it says that Delhi sells 480 sandwiches per day at the price of $6 each. Right? Then market research showed that 10-cent reduction in price results in 40 more sandwich sales. Right? Then what would be the best price so that we can maximize the revenue, right? So let's do that. All right, so first we're gonna we need some variable, so I'm gonna use x. Let x be the number of 10-cent price reductions. All right. Right, so this is just a number of price reductions. So for example, x is 2, then it's going to reduce by 20 cents. So the price is going to be 580. Right? But anyway, right, so then we can write the price function. So price. Right? So price P is equal to, right? You're going to start with $6. But we're going to do x reduction, so x 10 cents reduction, so it's going to be 0.1x, right? So this is a price function. Then if you want to revenue, we just have to multiply price by the number of sandwiches they would sell. So revenue would be, I'm going to call it R of x, right, is going to be price, which is $6 minus 0.1x, right? So this is the price. Then multiply by number of sandwiches that we can sell, Delhi can sell, right? 480 is the beginning, so this is at the full price, right? So if you do x 10-cent reductions, then you're gonna be able to sell 40x more sandwiches, right? So you can see that this part right here is definitely the price, right? And here is the number of sandwiches. Right? So this will give us the revenue. Right? Let's just multiply out and see what you can get. Right? 6 times 480. Let's see. So 6 times 0 is 0. Right? 6 times 8 is 48. And 6 times 4 is 24. So 2,000, 4 plus 4, 880. So I'm going to just clean up a bit, right? Then 6 times 40 would be, 40x would be 240x, right? Right, negative 0.1x times 480 would be minus 48x, right? Negative 0.1x times 40x gives you negative 4x squared, right? This can be cleaned up as, let's see, I'm going to have negative 4x squared first, so that's this guy, right? Combine these two guys together. All right, so that's going to be, let's see, 240 minus 48 is 192. So it's going to be plus 192 X, right? Then you have 2,880. So plus 2,880. Right? So we have a revenue function. Right? So we're going to take the derivative so that we can find the critical number. Right? So take the derivative of this revenue function. Right? Then let's see, derivative of that would be put 2 in front. So negative 4 times 2 would be negative 8. X, subtract 1 from the power, so it's just going to be X. Alright, derivative of 122X is just a 122. Oh, sorry, 192. Right, 192. And the derivative of 2,880 is 0, since it's a constant. Alright, so we're going to set that equal to 0. So we'll get, alright, so first I'm going to subtract 192. You get negative 8x is still on the left hand side. Right, then you're going to have minus negative 192 on the right. Right, then we can just divide the equation through by negative 8. Right, that way we can isolate x. Right, negative 192 over negative 8. Right, negative divided by negative, so you can cancel that, so the whole thing is positive. Right, so 100, let's see, 19 can have 2 8s, so it's a 220. Right, and so 2 times 8 is 16, so 32. So 4 times 8 is 32, so it's 24. Right, so when x equals 24 is a critical number. Right, so we just have to make sure that at the critical number, this revenue function is the largest. Right, so I'm gonna just go ahead and do the number line just to make sure that you're gonna have an absolute maximum at the critical number. So you can see here it's a critical number is 24. Then we're gonna look at the sign of the derivative, so r prime. Right, so try any number less than 24. I like 1, so I'll just try 1, or you can try 0 if you want. Right, if you plug in 1 here, you have negative 8 times 1 plus 192 is definitely positive. Right, on this interval you have a positive derivative. Right, and anything bigger than 24, so I'll probably try, I don't know, 30 or something like that. Right, then if you plug in 30, and it's going to be negative 8 times 30 is negative 240, plus 192 is definitely negative, so you have a negative here. Right, so the revenue function is actually increasing because derivative positive before this critical number 24. After that, since the derivative is negative, it's decreasing after 24. Right, this will tell you that we definitely have the maximum value at x equal 24. So you're going to have the absolute maximum at x equals 24. Right, since we're actually, how much should the deli charge? We're looking for the price, so price P that we're looking for would be, right, 6 minus 0.1 times x value. We just found that the x equals 24 will maximize the revenue, so plug in 24. Right, so this is going to be 6 minus 2.4, so that will be 3.6, which means that the best price would be $3.60. right? So that's the answer, right? So this just means that if you set the price at $3.60 per sandwich, you will be able to make be able to maximize your revenue. All right, that's it. I hope that this was clear.